In this video, I'm going to do another example of a linear regression problem, or actually a series of problems that are connected with linear regression. I'm taking this off of mock exam number 1. As you can see here at the top of the page, we're looking at questions 27 to 31 on mock exam number 1. Now this graph right here is just sort of for your information. It shows the behavior of the gas price over quite a long period of time. The gasoline price tends to be kind of cyclical. It usually rises to a peak somewhere around Labor Day, and then it drops off after that and resumes the pattern for the next year. We're not looking at the entire set of data that is captured by this graph here. As you can see when you scroll down, we're actually looking at a small piece of it. We're going from January of 2005 to March of 2009. And we're asking you to use the list number 1 for the X values, which would be the number of months after January of 2005, and the Y values, list 2, would be the price of a gallon of gas in cents. Now I have some instructions for you here right at the bottom, or right at the top of page 11, that explain how to get the X data quickly keyed into the calculator. It's very tedious to type it in by hand, so you should definitely take a look at this. If you can make it work for you, it really is very fast. So really the only data you need to key in would be list 2, which would be the Y data, the price of a gallon of gas in cents. And once you get it keyed in, then you're ready to go with the first question here. So question number 27 says, what is the least squares line for the gasoline price data? Round all decimals to the thousandths place. So let's go to the calculator, and I've got the data already keyed in, as you can see here. So the first thing I want to do is run the regression equation. Remember that this command defaults to list 1 for the X values and list 2 for the Y values. So I'll just run it. And right there you can see the slope and the y-intercept. Also the coefficient of determination and the correlation coefficient, both of which we're going to be interested in later. So let's take a look at that question there and see if we can figure out which one is correct. The slope is 1.669 if it's rounded to the thousandths place, and the y-intercept would be 244.693 if rounded to the thousandths place. So I'll go back to the mock exam there, and it looks like choice C would be the one we want to go with here. It's the closest one. Now it says 692 as opposed to what I was saying was 693. I may have just truncated that when I typed the question, or I may have miskeyed it slightly. It'd be very easy to miskey one of the decimals like that. But anyway, I'm going to go with choice C for that. Let's look at the next question here. It says, what is the practical significance of the slope of the regression equation for the gas price data? Now, as I mentioned in the other video, a lot of people struggle to interpret slope, and that's why we do it as a multiple choice question when we actually have it on the test. It's a lot easier to answer this question if you know what the units of measure are that are attached to the slope. Now, I was saying before, the units of measure are always y units divided by x units. In other words, response variable units divided by explanatory variable units. In this particular case, the y values, the response variable values, are cents per gallon, or cents, and the x variable, or the explanatory variables units, would be months. And so I'm looking at the choices here. It says in A, between the years 2005 and 2009, on the average, every month the price of gas increased 1.669 cents. I'm going to go with that. That is correct. So for the next question, number 29 says, what is the practical significance of the y-intercept of the regression model? Let's go back and refresh to see what that is. The y-intercept was 244.693. Now, when you're interpreting an intercept, whether it's a y-intercept or an x-intercept, it's always really helpful to think of what does the 0 coordinate mean in that particular context. Whenever you graph a line, if it has x and y intercepts, then there's always a 0 involved as one of the coordinates. The y-intercept is 0, in this case 244.692, and the x-intercept would be something different. So what does that 0 mean? Well, in this case, the 0 would be the x value, and that represents the months after January of 2005. So when we go back here to the mock exam, it says in choice A, the month in which the gas price in cents per gallon according to the model would be the same as the gas price according to the actual data. No, I don't agree. That's false. Choice B says, according to the model, it is the price in cents per gallon of gasoline in January of 2005. I'll go with that. That's correct. It's choice B. Now, number 30 says, according to the regression model, what should the gas price be for August of 2009? Round your answer to the 10,000th place, i.e. to the nearest tenth of a cent. Okay, well, let's take a look here. You notice that the data stops at x is 50, which represents March of 2009. Now, August is 5 months after March. So the x value that would correspond to August of 2009 would be x equals 55. And so what we want to do is input that value into the regression line and see what comes out as a y value. The easy way on the calculator to take care of that would be as follows. Let's get the data graphed. So we'll fire up the stat plot. We're going to be asked for this later anyway, so we might as well get it done now. Let's turn on the plot. It's already set as a scatter plot. It's already set to look in list 1 for the x values and so forth. So the only other thing we would need to do at this point would be to go and put the regression equation in y sub 1. So to obtain that, we already ran it, remember. Go to the VARs menu. Go to number 5, go to equations, and then you can see Reg EQ is highlighted there. Just press enter, and the regression equation is now stashed in y sub 1. And so if we press zoom 9, we get a graph with the data scatter plotted and also the regression equation there. Now you can see that this data is not very linear at all. In fact, it looks just like the graph we saw in the mock exam. It's cyclical. There's an oscillation that's taking place here. And we're not going to have a very good model here if we're using a linear equation. But anyway, to answer the question, let me first clean up the window just a bit. I always like to do this just to make the graph look better. So I'll run that out to 60, let's say. And by the way, a word of advice, when you're trying to do this process that I'm going to do next, if the calculator is unable to see that particular x value in the window, it's going to kick out an error. So that's why I'm bumping my x max out to 60, because I'm going to be inputting x as 55, and I want to make sure not to get an error. Anyway, the y scale or the x scale there, let's change that to 5. That should be good. And then for the y scale, the y values, let's see. Let's go from 0 to 500, nice and clean, and then let's make the y scale 100. Don't ever change XRES or anything below that. Just make sure you stop at Y scale. So now if I graph that, here is my scatter plot again, and there's my regression equation. So again, we're trying to find out what does the model say the gas price would be in August of 2009. So to do that, we'll go to second trace, and we want to input a value. So we'll press number 1, and we're looking for x is 55. So if you input that value, you can see the output right here. It says y equals 336.478. If you round that to one place, it would be 336.5. And so if we go back to the mock exam here, let's scroll down to the question again. According to the regression model, what should the gas price be for August of 2009? I'm going to go with choice D right there. That looks like the correct one. Now, question 31. It says, scatter plot the gas price data and superimpose the regression equation over the scatter plot. Based on the graph, the correlation coefficient, the coefficient of determination, and so forth, which of the following are true? Mark all which apply. Now that little instruction right there, mark all which apply, means that there could be more than one correct answer. It doesn't guarantee, but there could be. So let's take these one by one and see. Choice A, it says, based on the combination of the regression equation with the scatter plot, one can see that the gas price is negatively correlated with time. Let's look at that again. Well, if the gas price was negatively correlated, then the slope of that regression line would be negative. But it's not, it's positive. And so that's false. It's not negatively correlated. So I would reject A. I'm not going to mark that one. Choice B says, using the model to predict the gas price, or using the model to predict the price of gasoline for August of 2009 is an example of interpolation. Well, August of 2009 is outside of the boundaries of the data set. If you recall, the data set stopped in in March, or was it May of 2009? Let me check. I can't remember. It was March of 2009. And so August of 2009 is outside of that range, and so therefore that would be extrapolation. It's outside of the boundaries of the data set, so it is not interpolation. When you interpolate, it means you're within the confines of the data set, either on the y-axis or the x-axis or both. But in this case, we're outside of the confines of the data set, and so we are extrapolating. B is false. Choice C says the linear regression model fits the gas price data well enough to be of use. Does it really? Let's take a look again here. If you look at the picture, you can see that actually it doesn't. The data is oscillating quite a bit, and in particular when you look at the correlation coefficient, let's go back and get that again. The correlation coefficient is 0.416. It's very small as far as these go, and too small to be of use. I always like to say a good rule of thumb is when your correlation coefficient is above 0.75, or when the absolute value of the correlation coefficient is above 0.75, then it's linear enough for our purposes. So in this case, no, it's not very linear at all. And so I would say that choice C is also false, so I'm not going to mark that. And then finally, choice D says the linear regression model accounts for more than 50% of the explained variation in the data set. Well, again, let's take a look. The coefficient of determination right here, the r-squared value, it's 0.173. That's the percent of the variation that's accounted for by the model. So in this case, it'd be about 17.3%, and it's nowhere near the 50% that's claimed in the problem right here. It says the linear regression model accounts for more than 50%. No, that's false. So A through D are all false. That means the correct answer for 31 would be E, none of these. And regarding number 32, let's see, it's not actually part of that series, but we can still tackle it. It says, what conditions would need to be satisfied in order to say that the change in the variable x causes a change in the variable y? Now you got to remember that there's a difference between causation and correlation, right? Causation always implies correlation, but the converse is false. So in other words, just having correlation does not imply causation. So what do we want to see here? That would be true. When possible confounding variables have been ruled out, that's very important. When the correlation between x and y is close to plus or minus 1, yeah, we like to see a nice high r squared or r value there. That would be good. When an experiment reveals that a change in x causes a change in y, that's very important, because you can never infer causation from an observational study, which is what that was. We were looking at, or which is what we typically see with regression. So I'd go with choice D on that. It'd be all of the above. That sounds correct to me. Anyway, I hope this helps.